Now we're going to have a look at a slightly more difficult integration problem. So we still want to find an area. Find the area contained between y equals fx and the x-axis. As this graph is nice and easy to sketch, it's advisable to do so. So we've got a factorised cubic. Things to notice, it's a positive cubic and it has roots at 0, 1 and minus 2. So we can draw that. Our graph will look something like this. So the area between the curve and y equals fx will be that area there. Okay. We do spot a slight problem here though. This area here is absolutely fine. That's the kind of area we were looking at in the previous example. So we know it's going to be an integral. But this area here, remember when we met the definition of area as an integral, we said it was the sum of y times delta x. Delta x was that small change in x. That will always be positive. However, this y value here is negative. So if we do negative times positive, we're going to get a negative answer. All of this area will come out as a negative area, which means that I cannot do this as my integral. If I did that, I would get positive areas for all of this bit, but then negative areas here, and my areas would somewhat cancel out. So I can fix that problem by splitting my integral. I can do it first of all from minus 2 to 0. So remember, we're integrating y, and y is our function of x. And then I need to do a second integral here. Okay, so between 0 and 1 of exactly the same function. However, as I know this area will come out as a negative, I need to subtract that area, effectively adding the area on. I'm subtracting a negative number and therefore adding it. I know this will be negative, so I need to break my integral into two separate parts. I'm just going to colour code this bit green, just so that when I change to a green pen, we know which area I'm talking about. So let's do this top integral first. So this bit here, 0, minus 2. I need to expand these brackets because just like differentiation, I need everything in index form. So I'm going to get an x cubed. I would get minus x if I expanded these brackets. Times by x again gives me minus x squared. And then I would get a minus 2. Again times the x, I get minus 2x. Sorry, there I would get a positive x. So I get positive x squared dx. Okay, let's integrate this. So remember square brackets, because I'm saying there's more work to do here. So I'm going to get x to the 4 divided by 4 plus x cubed over 3. Remember, always write the power first and then what you're dividing by. It's just less prone to errors. X squared divided by 2. So I just get a minus 1. And I'm going between minus 2 and 0. Okay, fit one more bit on this board before we need to change boards. If we substitute 0 in here, I'm going to get 0, 0 and 0. That will always be the case in the first year. In the second year, we'll need to take a little bit more time because some functions, when we plug 0 in, do not result in 0. Cos x, for example. Minus, so remember I always take away this bottom limit, minus 2 to the 4 over 4 plus minus 2 cubed over 3 minus 2 squared. That's going to give me positive 2. That's going to give me a negative 2, so they will cancel out. and I'm left with minus 8 over 3. So I've got 0 minus 8 over 3, which gives me an area here of 8/3. So I know that this red area here is 8/3. Okay, now let's do that second integral. So we know what it will integrate to because it is exactly the same function. So I'm going to substitute in 1 first of all. So I'm going to have 1 to the power 4 over 4. And then I'm going to have 1 cubed over 3, and then minus 1 squared. I'm then going to subtract 0 substituted in. Again, I know that all of those will be 0. So you can see I've saved myself a lot of work here. I know the integral, so I can just substitute my limit straight in. I don't need to do the whole integral again. It just wastes time. So let's see what we get here. Remembering this is the green area. I'm going to get 1/4 plus 1/3 minus 1. So 1/4 plus 1/3 minus 1. Gives me minus 5/12. As we expected, a negative area, as we explained earlier. So what am I going to do? Well, I'm just going to take the positive of that number. So this area here, remember area, not the value of the integral, is just 5/12. Final step, if I want my area that I was originally asked for, I just need to add these two areas. Sorry if I went off the screen earlier. Together, 8/3 plus 5/12 is equal to 37/12. Okay, so quick recap of the key steps we've done there. We've sketched it. Because it was easy to sketch, it helped us see something. We had a positive area and a negative area, which meant we had to split our integral. Anything below the axis will result in a negative area. First of all, I did my positive area between minus 2 and 0, simplified everything down, and got an area of 8/3. Then I moved on to my negative area, again substituted in, didn't bother integrating again because it's the same function, and as predicted I got a negative area. If you ever get a sign that you're not expecting, just check through your work for errors. Then I added the two areas together. Again, notice that I didn't use the negative 5/12, I just turned it positive. I knew that that represented the area and the areas should be positive. Add them together, I get my final answer, I've answered the question.